I'm going to talk a little bit about loops. If you've programmed in other languages before, then you would have probably encountered for loops and probably also while loops and do while loops or some variation of those things. R has these features. I think I only show for loops here, but there's other kinds of loops if you're interested in those. I think for loops are most of the time the most convenient kinds of loops available if you actually need to perform an operation sequentially. A fairly common reason to use a for loop is to perform some action that you want to perform for each case in the data set. A loop is not the only way to do this, but it is one way to do this in a way that many people find easy to understand. So I am going to show you an example of that, a very simple example. The first thing I'm going to do is set a variable x to 0. So here's that variable. It contains the value 0. That's it. And then I'm going to run this code. The first line here says for item in score and has a curly bracket after it. That's how you initiate a for loop. The key word there is for. That's a special term in R for initiating a for loop. And it means that you are intending to loop through all of the items in a set of items, a list or a vector, one at a time. So after for, I am going to specify what I'm looping through in parentheses. The first thing in the parentheses, which I've called item here, is an arbitrary new variable name. This is not an existing variable. This is a new arbitrary name I'm specifying right now for my convenience, just for the for loop. It will continue to exist after the for loop, but I'm probably only going to use it in the for loop. Because this is going to be overwritten in the course of the for loop, you want to avoid using a variable name that you're already using for some other purpose, because if you use it here, the loop will overwrite it. Then in is a key word. That's not arbitrary. That's one of the control words for specifying the for loop. And score is the name of some existing set of things that I want to loop through. In this case, score is a vector. It doesn't have to be. It could be a list or some other data type, but in this case, it's a vector. If I run just score, you can see it's a vector of 20 values from the data frame that we're working with. So for item in score tells R that I want to loop through all the values in score and temporarily store each one in the name item so that I can do something with it as it's looping through. And the curly bracket tells R that I'm ready to start specifying what I want to do with each of the scores. So you can think of this entire line as saying, for each item in the set of values score, do the following steps. And here is the only step I'm specifying in this particular for loop example. All it does is it takes x, which I just created and assigned the value 0, and it reassigns it a new value. That new value is going to be x plus item. Item is one of the scores, one at a time, and each time x is going to get replaced by whatever it was before plus whichever score we're currently working with. So this is an intentionally simple example that does the same as something that we could do much easier in a different way. But it's to illustrate a point. The close bracket tells R that I'm done specifying the instructions to perform for each item in score. So this whole thing together will set x to 0, go through all of the scores, and add them one at a time into x, and replace x with whatever it was before, plus each item. So by the end, x should be 0 plus the first item, plus the second item, plus the third item. In other words, the sum of all of the items. Let's check to see if it worked. I'm going to run this code, and then look at x. It's 117. The sum of the score vector is 117. The loop worked as expected. You would never do this in real life because we have this sum function already, and because there's much more efficient ways to sum a vector besides adding the elements one at a time. But this loop simulates what you would probably do if you were trying to add together the elements of the vector using a paper and pencil. So let's look at a slightly more complex example. For this example, the first thing I'm going to do is learn what the length of score is. I already know that this data frame has 20 cases in it, but this would be a way to remind myself if I wanted to know. Score has length 20. There's 20 elements in score. So I can do 1 colon length score in order to get a vector of integers from 1 to 20, because that's what colon does. And that's a handy thing to do for looping purposes sometimes, because I know that those 20 integers will uniquely identify each observation in the data set, because those observations are in a particular order. And so one of them can be called the first one, and another can be called the second one, and so forth. So it's sometimes useful to loop through each observation's index using this 1 colon length type of notation. So in this example, I am going to initialize x to a vector of 20 zeros. Let's look at x just to see. X is a vector of 20 zeros. That worked because rep is a repeat function that takes this element, 0, and repeats it 20 times. And then I'm going to loop through I in 1 colon length score. 1 colon length score, remember, is the vector of integers from 1 to 20. I is an arbitrary name that I'm specifying right now. And I'm using I because it's a very common variable name for an indexing variable in lots of programming applications. So here I'm thinking of I as the index, and I'm going to loop through all of the indices of the scores. And for each of those, I'm just going to run one line of code again. And this is going to be to find the ith element of x, that is the vector x subsetted to just the element that has position I. Then I'm going to assign a new value to that element. And that new value is going to be the ith score plus the ith age. That is the element of score that falls in that same position, plus the element of age that falls in that same position. Again, this is a dummy example. You would never actually do this because there's an easier way to do what it's doing. But if I run this code and then look at x, I see a vector of 20 values, and that vector corresponds to score plus age for each participant separately, which of course we can just get by typing score plus age instead of doing this overly complicated loop. But this is a way of illustrating that the loop worked as expected. And this kind of a loop could be useful if you had a purpose in mind that was more complicated than, say, adding score to age. Like if you, for example, wanted to add the previous participant's score to everybody's age. That wouldn't work for the first participant, but maybe you're only going to do it from the second participant on. I don't know why you would want to do that, but I'm sure you're all creative and have some unusual circumstances you find yourselves in once in a while.